So now we will see how to represent a vector quantity in cylindrical coordinate system. Okay, so we have seen that if you are having rho 1 phi 1 z1 and rho 2 phi 2 z2, you cannot represent it as rho 2 minus rho 1 as rho component and phi 2 minus phi 1 as rho phi component and z2 minus z1 as z component. Okay, because all the three components are not going to have the same units. Okay, that's what we have seen. Okay, now suppose if I represent the units of if I represent a force vector, I can represent it as 2 into aero cap. In cylindrical coordinate system I am representing, I can represent as 2 into aero cap. So this is rho component plus 5 into a phi cap plus 7 into az cap. 7 into az cap. So this is how I can represent a vector. In cylindrical coordinate system. Its units are nothing but what? Its units are nothing but Newton. So the units of rho component is Newton. The units of phi component is also Newton. So the units of z component is also Newton. Or I can represent some displacement vector as 2 aero cap plus 5. We'll take another vector. Let us say 3 aero cap plus 4 a phi cap plus 6 az cap. So this displacement vector has the units meters. Understood? Okay. So this is how we have to represent the vector. You have to represent the vector in cylindrical coordinate system. But whenever you are representing a vector in cylindrical coordinate system, you have to specify at what point you are representing the vector. So that means this vector is specified. Let us say this vector is specified at a point 1 comma pi by 6 comma 2. Okay, 1 comma pi by 6 comma 2. So that means what here? So this is, let us say this is z axis and this is x axis and this is y axis. Okay, so rho is the normal distance from the z axis. Rho is the normal distance from the z axis to any point on the curved surface area of the cylinder. And pi by 6 represents what here? Pi by 6 represents phi. So it is the angle measured with respect to what? With respect to x axis. Okay, so let us draw a line that is parallel to what? That is parallel to x axis. So pi by 6 means 30 degrees. Let us say from here to here 30 degrees. Okay, so let us say this is rho. And this angle is phi. Phi is equal to 30 degrees or pi by 6 radians. Okay, so with this radius rho, you can form what? You can form a circle like this. Understood? So that point here, so this is nothing but what? This is nothing but 1 comma pi by 6. So now the distance from here to here will give you what? Will give you the z component. Yes or no? What is z component? 2 units. That means the distance from this point to this point is 2 units. So here this point is 2 units. Understood? Let us say this point is 1 comma pi by 6 comma 2. Okay, so now at this location rho direction, that is rho direction will be rho direction can be represented by aero cap. So along this direction you are having what? You are having aero cap, and if you draw the tangent, it is going to point in this direction, that is a phi cap, and this is aero cap, and az cap is going to point in this direction. Understood? Okay, so you are representing the vector at this point. This point is 1 comma pi by 6 comma 2. Okay, so this point is 1 comma pi by 6 comma 2. So at this location the direction of aero cap is going to point in this direction, and the direction of a phi cap is pointing in this direction, and the direction of az cap is pointing in this direction. Understood? Okay, now here at this point you are representing a vector. Force vector, which is having 2 units. Okay, 2 units along rho direction. So that means at this point you have to move along rho direction by 2 units. Understood? Okay, that is going to give you the rho component. And at this point you have to move along a phi cap direction by how many units here? 5 units. Okay, so that is going to give you a phi component, and if you move along az cap direction by 7 units, then it is going to give you what? It is going to give you the z component. Understood? So that means this vector is representing 2 newtons along rho direction, 5 newtons along a phi cap direction and 7 newtons along a z cap direction at this point. Understood? Now if suppose I have represented another vector, let us say f bar is equal to 3 aero cap plus 4 a phi cap plus 5 az cap. So I have represented this force vector. Let us say this is force vector. Understood? Okay, so now I have to specify at what point you are representing this vector. So I am going to give you the point here. Let us say this point is 2 comma pi by 3 comma 2 comma pi by 3 comma 1. Okay, 2 comma pi by 3 comma 1. So rho value is 2 here and phi value is pi by 3, that is 60 degrees. Yes or no? Okay, and this is z value. Now I am going to represent this point here. Now here let us say z value is 1. So let us say this point is 1. Okay, z value is 1. The distance from here to here is, let us say, 1 unit. Okay, so now at this location, so draw a line parallel to x axis. Rho value is 2 and phi value is 60 degrees. So from here you have to move to an angle 60 degrees. Okay, so with respect to x axis you have to move to 60 degrees. So here, so this is phi is equal to what? Phi is equal to 60 degrees. Now this radius, the normal distance from z axis to any point on the surface of the cylinder, this rho value is equal to 2 units. Okay, so with this radius just form a circle here. Okay, you can form a circle like this. Understood? Okay, so this rho value is 2 and this angle is what? This angle is 60 degrees. Now here at this location, aero cap direction is going to point in this direction and a phi cap direction is going to point in this direction and az cap is going to point in this direction. So this is the point here. So what is this point? This point is 2 comma pi by 3 comma 1. 2 comma pi by 3 comma 1. Okay, so now at this point here, this vector is defined. Okay, so in order to differentiate between these two, let us consider this as f1 bar and this as f2 bar. Okay, so f2 bar is defined at this point. Understood? So that means at this location here, first you have to go to this location. So at this location, if you have to draw aero cap, a phi cap and az cap. So that means this is aero cap direction at this point and this is a phi cap direction at this point and this is az cap direction at this point. Okay, so here this vector represents what? You have to move 3 units along aero cap direction. You have to move 3 units along aero cap direction and 4 units along a phi cap direction and 5 units along az cap direction. Then the resultant you are going to get some vector. Yes or no? So that vector is neither along aero cap nor along a phi cap nor along az cap at this point. Yes or no? Okay, so this is how you have to represent the vector in cylindrical coordinate system. Now one more point here. If I ask you what is f1 bar plus f2 bar, can you do f1 bar plus f2 bar here? Can you add these two vectors directly? Tell me, can you add these two vectors directly? No, you should not add these two vectors directly. Why? See here, if you go to rectangular coordinate system, okay, so if suppose I have given f1 bar is equal to 3ax cap plus 4ay cap plus 5az cap and f2 bar is equal to 2ax cap plus 3ay cap plus 4az cap, like this I have given. Understood? Now if I ask you f1 bar plus f2 bar, then what you will do here? You will add this x components. Yes or no? Why you are adding the x components here? Because the direction of the x component here and the direction of the x component here, both are pointing in the same direction or not? In rectangular coordinate system, we have seen that the direction of ax cap will be always parallel to what? Will be always parallel to x axis. Understood? Okay, so the direction is going to be fixed. The direction of ax cap is fixed in rectangular coordinate system. So here ax cap and here ax cap, both are pointing in the same direction, that is parallel to x axis. and here 4 ay cap and here 3 ay cap. So these two components are pointing in the same direction, and hence you can add these two components. And az cap and az cap both are pointing in the same direction, and hence you can directly add these two components. So finally what you can write, 5ax cap plus 7ay cap plus 9az cap. So you can write directly in this manner. Understood? Y means both the x components are going to point in the same direction, y components are also pointing in the same direction, z component are also pointing in the same direction, and hence you can directly add these components. But here, see here, so now here for f1 bar here, if you consider for f1 bar, okay, so it is defined at what? It is defined at this point 1 comma pi by 6 comma 2. So that means at this point. Understood? So at this point the direction of aero cap is in this direction, and a phi cap direction is in this direction, and az cap is in this direction. Understood? And you have defined another vector at another different point, yes or no? So that point is 2 comma pi by 3 comma 1. Understood? Okay, so that means here that point is 2 comma pi by 3 comma 1 at this location. We know that as phi value changes, yes or no? As phi value changes, see here phi value is pi by 6, yes or no? Here phi value is pi by 6 for this vector, and here phi value is what? Pi by 3. We know that we have already seen the dependence of aero cap and a phi cap are going to depend upon what? Are going to depend upon phi values, are depending upon phi values. We have already seen this or not? Okay, aero cap is equal to cos phi x cap plus sin phi ay cap. We have derived all those things, yes or no? So aero cap and a phi cap are going to depend upon phi value. So as phi changes, the direction of aero cap and a phi cap are also going to change. Yes or no? Yeah. So now for this vector, phi value is different, and for this vector phi value is different. Understood? So that means here the direction of aero cap is not parallel to what? The direction of aero cap at this point. Yes or no? Yes or no? Yeah? Because phi value at this point and at this point both are different, and hence the direction of aero cap here and the direction of aero cap here both are not parallel. Both are not going to point in the same direction. So whenever both are not pointing in the same direction, you cannot directly add those components. Understood or not? Okay, now similarly at this point a phi cap direction is pointing in this direction, here also here it is pointing in this direction. Okay, since phi value is different from here to here, the direction of a phi cap is also going to change. Okay, you cannot say this a phi cap defined at this point and this a phi cap which is defined at this point, both are not parallel. Understood? Okay, so and hence you cannot add these phi components. Okay, you can add z components here. The direction of z is going to point always parallel to what? Parallel to z axis. Understood? If they ask to determine f1 bar plus f2 bar, okay, and one vector is defined at one point and another vector is defined at another point whose phi values are different, So in that case, the directions of aero cap, a phi cap and az cap at this point, and the direction of aero cap, a phi cap, aero cap and a phi cap at this point are going to be different. Only az cap directions are going to match, and hence you cannot add the two vectors directly. Understood or not? Okay. Okay. So now if suppose this vector is defined at the same value of phi. So that means let us say here pi by 6. Let us take here pi by 6. Okay. So that means phi is equal to what? Phi is equal to 30 degrees. So if I define this vector at pi by 6, that is at 30 degrees. Okay. So for this vector is also defined at the same phi value. So if phi is not changing, then the direction of aero cap, a phi cap and az cap are going to be same for both the vectors. Now in this case, you can directly add here. In this case, you can directly add these two vectors. So in this case, if they ask f1 bar plus f2 bar, then you can add the row components because both are parallel here, and a phi cap both are parallel, and az cap both are parallel. So all are pointing in the same direction. So aero cap are pointing in the same direction, a phi cap are pointing in the same direction, az cap are pointing in the same direction, and hence you can add row components and phi components and z components directly in this case because phi value is going to be same. Understood? If phi value changes, then only the direction of aero cap, a phi cap is going to change. Understood?